We are here at page 2 of 4.6, and this is where we're going to practice the graphing of linear inequalities. We talked about it on the first page, but now we're going to actually practice doing it together, and we'll just rehash kind of what we talked about on the first page again. So we're going to keep our goal in mind as always all throughout this chapter. We wanted to become experts at graphing linear equations. Experts means we want to be efficient, elegant, accurate, both from the graph to the equation, and then the reverse, from the equation to creating the graph. So we can go backwards and forwards. We do it as efficiently, accurately, which in turn creates a nice, elegant way to do it. That's when you're talking mathematics about elegance, we're not talking about waltzing across the floor in the wonderful tux or glittery gown. We're talking about doing something that it looks like you make it look so easy. That's what elegant means in mathematics. But really, we've worked hard to get to this point. Okay. Now, but you say, now wait a minute. We're in a section on linear inequalities. Well, it's not going to change it. We're going to be able to use our graphing skills and apply them to graphing linear inequalities with just one extra little step. So let's recall again. When it was one variable and we had to graph a linear, when we solved a linear equation and we were graphing, when we were solving a linear inequality with only one variable, we ended up with an answer that we could graph on a number line. So it's just a one-dimensional, basically it was the x-axis before we knew to call it the x-axis, that's what it was. And then we would plot the point, okay, and we would shade one direction or the other, and we could do that either based on the direction of the less than or greater than, less than or equal to, or greater than or equal to, or based on a test point. And then we would either include or not include using brackets, or not include using parentheses the number itself. So that's what we did when it was just one variable. For example, we did one on the other page like this, but let's say like negative 2x plus 1 is greater than 5. And we would solve that and we'd get negative 2x is greater than 4, and then we divide both sides by a negative 2, and little red flags would be popping up all over the place because we said we were dividing by a negative. If you divide or multiply by a negative, it flips the signs. This would become x is less than 4 divided by negative 2 is negative 2. And so we'd draw our little number line, and we'd say, okay, less than means to the left of negative 2. So we would shade everything to the left. We wouldn't include it because it's just less than, so we'd have this little parentheses. And that would be how we would graph that solution set. It would be all these points to the left of negative 2. All those numbers would make that equation true. Now with two variables, you now have basically number lines in two directions. So instead of it being one-dimensional, you would have two dimensions, left to right and up and down. And so now you have x and y, and so solutions are ordered pairs. X comma y. Okay. And now the shading means that we're shading a space. So instead of getting a single number and plotting on a number line, we're getting a pair, x and y, an ordered pair that we plot on the grid. And now shading means that we're shading a whole section on one side of the line. And we can find that based on the direction. Here's where it starts to sound familiar. It's based on the direction of the inequality, either less than or greater than, left or right, bottom or top, if you're able to make that make sense to you. Or you can do based on direction or a test point. Okay, and up here I really should have included we shade based on direction or a test point. Both of those should be in the little thing. And we either include or don't include the line itself as part of it. Okay, so if we include it, it means that we had less than or equal, greater than or equal, and we'd use a solid line. If we don't include it, it means we just had less than or greater than, and we would use a dashed line for that. Okay, so that's the basic idea. Now, how we're going to do that, we'll talk about that on the lower page. We've hinted at it already on the previous page, but let's move down to some of the examples here, and we will talk about how we will apply our knowledge of graphing.